Hey, Yusuf, how we doing, buddy? Sorry about that, Yusuf. It's an auto mod. I have some news for you, Yusuf. I have some news for you, Yusuf. By the way, if you're still here, Yusuf, I need you to... Good, good. So, I am coming to the, I'm coming to the Theorem match on the 18th of December. So I'll be making my way down. That is, I wanted to let you know because you asked me to, Yusuf. Let me switch over. Alright. There we go. So I'm just letting you know, Yusuf, that's what's going on. I'm coming to the 18th of December. I'll be actually making my way over. Actually, should probably switch the camera. You know, your disembodied voice. You asked, how you doing, Yusuf? You asked when I was gonna be making my way over. Well, that is the time. Let me tell you, the plane ticket has been booked. I'll be there for like 3 weeks, so I'll be doing some touring around. To make sure I'm there that day. Yeah, I'm gonna be flying in like on that day at like 7 in the morning. So I'm gonna be spending like a full day just getting situated, and then hopefully making my way out there. I'm gonna be definitely making my way out there to Bowers and Pitsy, over to Lead and Salmon. So you asked me to let you know, and this is my hopefully formal notice. I'm letting you know. Only thing I gotta do is find some lodging. I'm not sure where I should find lodging exactly. If I should find it close to the stadium, or if I should find it, you know, somewhere closer to London proper. So, I'm kind of asking around, see if what would be the best piece of advice. I'll probably be taking some time and be like kind of searching around and finding what to do and all that jazz. And of course, going to games. That's only natural. There we go. I'm gonna get a few more people coming in here. I think that's important. Yeah, class. Ooh, baby. I'm okay. If you're gonna be there that day, Yusuf, I'm hoping you can be there. So we can meet up and we'll have a grand time at the game. So I'm looking forward to be honest. How have you been, by the way? You been good? Okay. Ooh, how's everybody doing today? All right. Proper tired today. Get some statistics in. Hopefully this is... No, this is not hard. How many classes do we have to go? 2, 3. Okay. Like a lot. Alright. And let me check this. Yeah. Wait, what? Yeah. Yeah. That's fine. That's fine then. That's fine then. Got just a few more to go apart from that, and then should be able to wrap that up. Alright, time is okay. Alright. We'll get started here in just a few minutes, and then we'll get going. Simple as that, ladies and gentlemen. Simple as that. Hope everybody is doing absolutely fantastic today. Hey, Planet. Good to see you again. How you doing, Planet? Glad you could make it. I know you have another class usually during this time, but I'm glad you could make it out here today. It's always a pleasure to see you. You're fine? Yes, you are fine. Well, that's good to hear. How was your weekend? You had a nice weekend? Nice chance to relax, or were you working all weekend? Hopefully you got a chance to work on a little bit of homework. Well, maybe. You're so excited. Very nice. So excited about what exactly? If you're excited about something, it's definitely got to be worth mentioning, so... What's going on with you, Planet? We're super excited. We're not only super excited, hopefully super excited about learning some statistics today. Maybe. You just did your first big purchase? Ooh, hello. Jasmine, good morning. Good morning to you. I'm waiting for a package. Well, if I may ask, Planet, what did you purchase? What's this first big purchase gonna be? I mean, I don't know. And by the way, I want to tell you, Planet, congratulations. Regardless of whatever it is, you earned your way to get that. Oh, there you go. I approve of this. Yes, your first Switch. Very good. Very good. And you earned the money. You did everything you could to earn that thing that you wanted. In this case, Nintendo Switch. I can respect that. I respect that a lot. Is that you got the Animal Crossing edition? So is that? I'm assuming that's what you're gonna play. Is just Animal Crossing. That's gonna take like hundreds of hours out of your time. Yeah, that game is super addictive. No question. That's awesome. Congratulations, Planet. Congratulations. That's amazing. I remember that first time where I got to... You gonna speedrun homework while I while waiting so I have all my time to play. Sounds like a pretty good idea. Sounds like a pretty good idea. Hmm. It's not a bad idea. Remember, though, you gotta pay. Everybody's gotta pay Tom Nook, alright? You gotta pay back Tom Nook for all the debt that you owe him. All them bells. Tom Nook, the best loan shark in gaming history. The amount of customization in Animal Crossing is unbelievable. Alright. What is going on here? Yes, I'm trying to refresh you, and you don't want to do anything. Hey, Sneaky Weasel, how we doing, my friend? I hope we're doing good. I'm doing absolutely fantastic. Do you have a good weekend there, Sneaky? Hopefully you got a chance to chill and relax and all that jazz. That works. Yeah, wait, camping with your cousins, respect. Respect, my friend. Very, very nice. Where'd you go camping? Locally, or did you go like the Indiana Dunes, or? Hey, Goldmash, how you doing? How you feeling, by the way, Goldmash? It was freezing. Yeah, it was actually pretty cold on certain days. Been watching a lot of ACNH on YouTube and Twitch, so got lots of help just watching. White Pines. I don't know why. I think White Pines, an hour and a half west of Belgium. Oh, okay. Respect on that. Well, as long as you had a good time, maybe made the use of the last of the remaining bits of good weather. Actually, it's weird. It's like 40 degrees. I walk outside, right, for an early class yesterday, and then I come back, and then in the middle of the day, it's like 70. I'm like, man, 30 degrees. It all suddenly changes. Suddenly, my jacket was like super hot, because now I went from 40 to 70. I'm like, okay, sure. It's weird. I'm like all in the space of like an hour and 15 minutes. You're feeling better, but you're still coughing. Can't stay for long. I'm watching Celtic and they're having. Okay, that's fine, Goldmash. Not a problem. All right, we'll get started here in just a couple more minutes, and then we will get going with what we gotta do. We gotta do things. Yeah. Today won't be too bad. At least I don't feel it would be too bad. Alright. Pretty simple. At least I think today is pretty simple. Alright. Alright. Actually, I gotta think of one thing here. Jasmine, like, are you gonna tell us when the test is due now? Yes. Yes, I will. This I can tell you eventually. Oh, I actually gotta do that too. I will tell you at the end of class here once we do finish there, Jasmine. I do promise you that. Weather is crazy. I was all wrapped up in the morning, went outside. Yeah, I know, right? It's weird. It's really weird. At least it's a cold. Okay. Jasmine, like, ugh. You're such an annoying teacher. Jeez. Everything all in due time. All in due time. I want to be sure. I want to be double extra sure I finish first and then I announce everything. Again, if you ever want transparency, I don't assume anything. So therefore, once I finish, then I go ahead and make an announcement. Because if I announce ahead of time and then we don't finish, well then you're going to be mad at me for not covering everything. And then you'll be like, well, what the heck? You know? And then you'll be like, well, you're not being consistent, Professor. That's not fair. And I'll be like, oh, I see. See, if you do the same thing every time, then nobody complains. Yeah, exactly, Yusuf. I'm hoping I have a great experience in London, too. I don't disagree with that. I'm hoping to get to see you at a match, my friend. That'll be after the semester's over, so. Okay, lyric all you like. Go Mash, you have yourself a good one. Alright, folks, let's get going here. Let's do some intros. Let's get going, alright. Okay, let's get started today. Welcome back to Tuesday. Hope a nice weekend. Alright, so today, ladies and gentlemen, we are going to be finishing up Chapter 8. Okay, Chapter 8 is the first section here on the agenda. We're going to finish that up here, and then hopefully we'll get into a little bit of section, or Chapter 9 here. So, there's only a couple sections here in Chapter 8, sections 8.1 and 8.2, just like Chapter 7. Only did a couple sections there. But all Chapter 8 is just Section 8.1 and 8.2. Now, we did talk about Section 8.1 here last week. That was, again, using the normal distribution here. We just made the one change to the standard deviation, which is, of course, taking the standard population standard deviation, dividing by the square root of the sample size, and we pretty much did the same things that we did here from the previous section, again, using normal CDF and inverse norm. Alright, now, for today, in section 8.2, we're still going to be using our same two guys here of normal CDF and inverse norm. Okay, this time, though, we're going to be looking at it from a slightly different perspective. Alright, so let me bring this up here. Yeah. So let's talk about proportions. That's what we're going to be doing here today, is referring to proportions. Alright, so in this case here, sample proportions and population proportions. So let's bring up the big board here. Let's do it. Alright, so this is going to be starting from question 4 from last time, from the previous handout here. So just to let you know, tippity tap, thank you very much for the follow. So let's take a look at question 4 here. We're going to talk about sample proportions and population proportions. And we'll discuss here, sometimes the book here, just to let you know, sometimes the book here kind of interchanges these two guys. I want to say for some reason it kind of interchanges it at times, but I just want to be at least pretty clear about what each represents. And you'll see exactly how I kind of separate the two. I usually just write it out right without the extra p's floating around. Alright, in any case, how do we find the sample portion, population portion? Alright, so I first want to make note of the notation here. First of all, P here is the population proportion. Okay, so we have P here being the population proportion. Alright, so the overall population. And P hat here is going to equal X over N, which is, this is P hat here, is going to be called the sample proportion here. So if we have a sample size, we said X is the number of people who said yes to your question, and N is the sample size. So let me repeat that one more time here. Let's say, for example, you have a survey. You ask, hey, do you like brand A or brand B to your sample? Let's say you ask, 50 people for just as a simple example here. Let's say 20 of them said, yes, I like brand A. Okay, you say, do you like brand A? They say yes. All right, then you would say 20 out of 50 people like brand A. All right, that's what the X is going to be, would be the 20, and would be the 50 here in this instance. All right, so that's essentially what P hat will represent. Now, what is important here is kind of like what we discussed here last time. Okay, so if you remember, there's two parts to every problem that we did here last time in the first section of Chapter 8. And that is, we looked at, number 1, we looked at a mean, and number 2, we looked at a standard deviation. Those are the two things that we looked at when we did, say, normal CDF and inverse norm. We had a mean and a standard deviation. So the question becomes is that how does that work within the context of proportions? All right, so let's look at question 5 here, and this is going to hopefully answer that question. So question 5, what is the standard deviation of a sample proportion? All right, so the standard deviation, again, this is the notation here for a sample proportion, is going to equal this guy right here. Now, this is a guy that probably you definitely would want to write down. This is the square root of the entirety of p, again, being the population proportion, times 1 minus p, all divided by the sample size of n. Okay, so again, please make note here, this is the population proportion that we are referring to here in this instance. All right, so we are definitely going to use this here as part of our standard deviation package. All right, however, that's only one half of the story. All right, the other half of the story is, well, what happens to mean here underneath these proportion types of examples? Well, what we need is we need to actually understand the central limit theorem for proportions. Okay, so let's talk about the central limit theorem for proportions, and then we'll get the answer to our question here regarding the mean, as you can see right here. So here's how it works. So the larger n gets, i.e. the larger the sample size is, the more the sample proportion will resemble a normal distribution. So the more we increase our sample size, so instead of 50 people, maybe we should ask 200 people, or maybe asking, 300 people. Okay, that would be a whole lot better and get us closer to that bell-shaped curve that we so often desire. All right, so that's essentially what we're after here in that particular case. Make sure you get that picture, no problems. Now, we do have some conditions that we do have to follow here, so I do want to talk about those. If we're going to have it work out the way where we're going to get the particular mean and standard deviation to work out exactly the way it is listed here on screen, we are contingent on one thing here, and that is, of course, we need this first condition to follow. So we have np times 1 minus p has to be bigger than or equal to 10. This basically ensures that we have a large enough sample size dependent on the proportion that we have, the population proportion, excuse me, that we have here, we're given outright within the problem. Now, what does this mean at the end of the day? What this means overall is that this basically means that the sample mean here is equal to the population mean. So that's essentially what this means here. So I'll put this in parentheses here for this. Okay, so the sample mean equals the population mean. All right, so that's what this u of p hat kind of means here at the end of the day. And here we have the standard deviation is exactly the standard deviation that we discussed up above. Okay, the square root of p times 1 minus p, all divided by the sample size of n. All right, so this is the central limit theorem for proportions. And once again, we're going to employ this tactic here in order to find probabilities and percentiles like we did before. Okay, so nothing different here in terms of how we're going to approach these problems. Calculator, button presses, and the whole 9 yards. But we do have to, of course, I'm going to take a look at some questions here naturally in order to find out some results. Let's go ahead and take a look at a couple of them. All right. So I kind of copied this down here. Why? Stop. All right. Second. All right. Let's go ahead and take a look here at this very first question, okay? All right, so this is number 17 on page 385. I'm going to kind of put this here on the bottom of the screen here for right now. Yeah, I'll separate this out just a screen. Okay. All right. So, according to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. Okay, so let's answer question A. What is the probability in a random sample of 500 adult Americans? Less than 38% believe that marriage is obsolete. Okay. So let's do this one out here. We do have a couple things we need to discuss. But while I'm putting this together here, do you guys think that marriage is obsolete? I don't know. Is marriage a washed up sort of thing? I don't know if marriage is a washed up concept, but let's see what you guys think. Do you think marriage is obsolete? Is getting married worth it anymore? No. Obsolete, no longer used, no longer produced or used. So, but do you think the concept is obsolete, Jasmine? Dancing around the question using a formal dictionary definition. I feel like lots of people feel that they like it. They feel like it is. Yeah, in a lot of ways, a lot of people do feel like it is obsolete. Some people definitely do. I know that for a fact. Some people absolutely don't want to get. No, not required like it used to be. I mean, that's true. It's not really required. But let's think of it this way, Alex. Let me add to that comment. If it's not required, do you feel like it's really that... If it's not required, do you feel it's necessary for you? So... It's absolutely not absolute. I mean, my only reason for marriage is for the aesthetic, so I guess. I can feel that. So you're like, the only reason why you want to get married is just like, okay, I'm kind of looking good with my partner, you know, and that's about it. But you feel like it should mean a whole lot more than just like the actual act itself. That's really interesting, actually, to hear. Is this actually a so this question here is actually, I don't think it's necessary. I'm impartial about it. If it happens, then it happens. If not, then it doesn't. Okay. Want to marry for love so I can be with that person for the rest of our lives. That's fair. Now this is, I know this question here. This is like one of the interesting questions, at least from what we can get for an actual practical application. Is because the trending societal attitudes is a little bit different. Now, I cares about my Harvard. I want a nice party for pics, and then I'm done. I want a nice partner for pics, and then I'm done. I see. It's just like, okay, it's gotta be photogenic, and then that's it. That's what my marriage partner is useful for. Photogenic pictures. I could respect that. Take the one requisite picture for the day. Ooh, okay. Then I'm going for the divorced aesthetic. I guess that's the thing. This happens to be a societal question. It used to be like, it's kind of like what Alex said. Okay, is it required? The answer to that is I don't feel that people think it's as required as it used to be. Like, it has to be a necessary thing. I feel that today some people are viewing it as more of like it's a, they feel like more it's easier to be in like a casual relationship than it is to be in a committed relationship. I think some people certainly view relationships that way. Again, you have your dating apps and whatnot that kind of trend toward that particular, as if I were to offer evidence, I'd be like, okay, what about your Tinders and Bumbles and all that stuff, all your dating apps? All right, they kind of show that, oh, well, a casual relationship may be a little bit easier than maybe having more of a committed relationship, and that marriage Marriage, they kind of look to their parents' examples, or they kind of look to other examples. They're like, well, marriage is not as necessary, and I don't want to deal with that drama as much as I really want to. But I'm not saying that people say, oh, well, that's wrong. Be like, that's what I've noticed over the years. I'm not saying it's not obsolete. I think that for people, it's person to person. If they think it's necessary for their life, I say you go ahead and do it, because that's your life, and you should be able to do whatever you want. What I'm saying is that from what society thinks about is it becoming more and more obsolete? The answer could possibly be yes. I saw that over in so true story. I saw that over in Japan when I was living over there. Is there were circles of people, like there were circles of people who would literally just disavow marriage altogether, and they would just form friendship circles. So, they'd be like, I don't want love, I don't want marriage, I don't want a relationship, we'll just be friends. It's all platonic from here. Now let's see what we got here. So, it's so sad people aren't loyal to their marriages. That's true, Sneaky. I agree with that. I feel better when they're with me. They want to be. Uh, feel better when they are with me because they want to be, than because they have to because it's their duty as a spouse to love me. That's true. Okay, which is why you don't rush into things. Very true, Sneaky. Always think about a big step such as marriage. Very important. Marriage is looked at as a piece of paper. Um, or we look at it just for the ceremony, but I believe it is much more than that. Okay. Okay. The ceremony is one thing. But okay, Jasmine, let me ask you this. What do you view marriage as in your own personal point of view? Because I agree, some people look at it as like, oh, you're married for the sake of customs or whatever. But you know what? Marriage should mean something special. I agree with you, Jasmine. But what does it mean to you? Marriage is supposed to be sacred, but society strips it from that. I agree with that. But I don't think you should let society dictate what marriage should mean to you and what your expectations of a marriage should be. Like, I agree with, like, for example, Planet saying, hey, marriage is something that should be a marriage should be something that say, hey, the two people together who truly love each other, right? And they want to be with each other. That's very important. It shouldn't be like an obligation because, oh, you're, cultural society demands you to be so because of this, that, and the other thing. Like, it should have, like, to me, it should have a meaning between those two people. Those. Marriage. What an interest. It's one of the most interesting questions in this book, I ain't gonna lie. I love this question. Societal trends are very important to watch. 100%. Yeah, it's supposed to be about the joining of two souls who love each other into one soul. Who want to be together because they love each other and not because of the obligations of culture and or family. And Christian marriage is what God made for us. I have a lot to say about this. Alright, that's a fair statement to say. That's a very fair statement to say. Now understand, Sneaky, I'm not going to get into religious arguments here. Alright? Because, honestly, you feel, believe me, what you feel religious-wise is all about you. So, like I said, I'm not going to talk about religion on this channel. But what I will tell you is that if that's how you feel about if that's how you feel about marriage, I think that's definitely perfectly fine. Because you have an expectation of what you feel spiritually wise about what marriage should mean to you. And I think that's perfectly fine. It's perfectly acceptable. So, like, marriage means something different to everyone. 100%. Marriage is a symbol of Christ's love for us and displayed between two people. My marriage should reflect that. Additional love and sugar. Okay. Much respect there. Much respect there. It means something. Yeah. Well, I'm not doing religious arguments here. Trust me. That's not what this channel's to teach mathematics. Mathematics. All right. But this channel's to teach mathematics. But like I said, everybody has a different metric about what they feel marriage should mean to them on a personal level. And if that includes something on a spiritual level, that totally makes sense to me. Because that's something that's very serious for them. For, in this case, yourself. Marriages can fall apart. That's true. That can happen. But that's part of, you know. Gotcha, Yusuf. All right. Okay. I just had to ask the question because it's so interesting. All right. In any case, all right. Let's talk about a couple things here. Let's take a look at letter A because we do need to actually do this problem. I promise you. I could talk about marriage all day, but trust me, like you guys, I could talk about marriage all day. But we do have to do this problem. All right. What is the probability that a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? So here we have less than 38%. Now I am going to point, I'll point out a couple things here in this particular problem. Okay. So let's talk about the two things that we do need here. All right, let's talk about the two things that we do need here. We do need to establish here a P, a population mean here. All right. So what is the population mean here? The population mean here in this case. So what is the population mean here? Now, Vince, 500 is not it. Because 500 is the sample size. Guys, the sample size here is 500. We asked 500 people. Okay, so we talked a sample of 500 people. So I won't say 500 is going to be our P here. We need our population mean here. So I asked 500 people and I said, okay, do you think marriage is obsolete? They tell me yes or no. Okay. And then they say, okay, I think yes, I think no. All right. 500 people is my N. Not 190 either. Remember. Let's go back here. Our sample mean here, all right, is going to equal our sample mean proportion. And let's put it as proportion here. Maybe that'll make it a bit easier. So let's go population mean proportion, population mean proportion, sample mean proportion. What do we have here for this particular problem? What is P going to equal here? It's not 190, though that's not a bad guess, but it's not. We want a particular percentage here in this case. What do you guys think that could be? All right, Victoria says 0.39, and that is correct. If you take a look here, they did a study, and they said 39% of adult Americans believe that marriage is obsolete. So, in fact, P here is going to be 0.39, okay? All right, so does everybody understand why we picked 0.39 as our P here? Again, the population proportion here will be equivalent. We're going to make the assumption that essentially, if it's going to follow normal distribution, it's going to be exactly that. Okay, it'll be the same as the population proportion here. Hey, Beast, how we doing, my friend? We have any questions about that before we move on? We'll donate $100 if you dump a bit of water on your head. No. I mean, I could dump a bit of water on my head, but it wouldn't make any difference. All I have is tea, my dude. And I happen to like drinking the tea as opposed to dumping it on my head. I'm not super hard up for cash, but alright. Next. Let's talk about what we're going to be doing here next. This is true. Water is a construct. Tea is real. There you go. Alright. So here's what we're going to do next. If we're going to do this properly here, we have a P of 0.39, we have an N of 500. Alright? So, let's take a good look here. P is 0.39, N is 500. Now, since this is going to follow a normal distribution, what we're going to use here is we're going to use Normalcdf. Alright? So just like we did last week, we're going to use Normalcdf here in this instance. Now, because we're using Normalcdf here, we still have the same four things that we talked about before. We have the less, we have the lower, we have the upper, we have the mean, and we have the standard deviation. Alright? The lower, upper, mean, and standard deviation. I'm doing great. Peace. How are you? Now, let's talk about what this is going to be here in terms of the numbers that we're going to be doing. Alright. I'm going to bring up the calculator here. But make sure you take out your calculator for this portion, because that's what we're going to need. Alright. So, for Normalcdf here, what we are going to be doing here is, since we want less than 38%, now normally what we do is we do like minus 1e to the 99. Now in this case here, remember that we're talking about percentages. So if we're talking about percentages, we go from 0% to 100%. That's essentially what we're doing here at the end of the day. So if we're talking about less than 38%, we could put our lower here as 0. And get second in bars. Normalcdf. We can just put 0 here. We could put our upper here as 0.38. We can put our P here, which is going to be 0.39. Alright, which is going to be our mean. Okay, we did talk about that before. And then finally, our standard deviation here is going to follow the same exact standard deviation that we have up here. Again, just like we did in this question, the square root of P times 1 minus P over N. Okay, we're going to go ahead and use that here in this particular circumstance. Okay, so let's go ahead and put that in. We're going to have the square root of 0.39 times 1 minus 0.39. And then this will be the factoring in of divided by 500. Now, if you have your calculator out with you, let's go ahead and plug these numbers in, first and foremost. Okay, now if you have the old school calculator here, you got to be a little bit careful, okay? If you have the old school calculator here, you got to be a little bit careful. You're going to hit second, and of course the square root key. And what you're going to see here on the screen on the calculator will be exactly how you should enter in that last number if you have the old school calculator for your standard deviation. So you do need to be a little bit extra careful, okay? Especially about how you're going to enter in this entire thing. Alright, so the first thing that you need to do is you need to actually add in another parenthesis, another left parenthesis actually. You need to hit 0.39 here. You're going to multiply that by another left parenthesis, 1 minus 0.39. You'll close that parenthesis off. Okay, then you'll close that parenthesis off. So then you'll have these two parentheses kind of with each other here. Then you'll divide by 500. And then one more parenthesis just like so. So as you can see here on the screen, this is how it should look for the standard deviation. This is going to be a little confusing. All right, so you should have it look something akin to this. Now, I want to be sure everybody's on the same page here. So again, should look just like what you see here on the screen if you have the old school calculator. All right, and we'll go ahead and paste it. Paste it. Okay. And so our final answer here in this case should be 0.3233. I want you to, everybody who got this, I want to make sure that everybody typed this in correctly on your calculator. So please type in "got it" on the chat, okay? And please type in "got it" on the chat if you got the same exact answer. Want to make sure everybody entered that last part in, especially the standard deviation is a little tough to enter it. So make sure everybody's on the same page here. And that's fine. Take your time, Sneaky. Just let me know. I want to make sure that you get the same answer here, okay? Well, the reason, okay, Victoria, the reason why the lower number is 0 here is because we're dealing with percentages, proportions. So we're only dealing between 0 and 100%, all right? That's why we're not dealing with like minus infinity in percent. That doesn't make sense. Or again, infinity percent here. We're only dealing with particular proportions, so that's why I set the lowest number here equal to 0 in this case. And we also followed the wording here in the problem here, Victoria, which was in this case less than 38%. So from 0% to 38%. Yeah, so with percentages here, Alyssa, we always talk about 0 to 1. Okay, or 0% to 100%. Yeah, you got to be careful about parentheses, Sneaky. So let's look at it one more time. Your last number should look exactly like this, with the parentheses in those exact spots. So one thing you can't do on the calculator is you can't skimp. So be sure that you have to be very careful. Make sure you don't forget anything here. This is especially true regarding parentheses. The calculator wants to do things in a very particular manner. Make sure you got that correct there. I hope you have the right numbers, just like you have here. 0, 0.38, 0.39. Did you remember to add a parenthesis at the end here? Oh, you got it? Okay. Okay. Alright. Let's move on then. It's fine. No problem, Sneaky. Alright. Let's try the next one here. We'll try letter C. This is part B here. Alright. Let us take a look at C here. What is the probability that in a random sample of 500 adult Americans, between 40 and 45% believe that marriage is obsolete? So, once again here for part C, we're going to go ahead and use Normalcdf. Alright. Now this part here, again, not too hard. The deal here is, again, we're finding the probability of between 40 and 45%. So we're just, again, we're just going ahead and plugging in, just changing the first two numbers, okay? Nothing too crazy. So we're going to have 0.40 0.45. And then keeping our same two numbers, the last two numbers here the same, 39, and the standard deviation here, 0.39 times 1 minus 0.39 divided by 500, all divided by 500. Alright, now we can keep the last two parts the same, that is not a problem. But let's go ahead and enter that into the calculator at the very least. Here's a trick for you guys. For people who have the old school calculators, by the way, just to let you know, here's a trick for you guys. Maybe you don't want to keep entering in these same numbers here over and over again. Remember that you can always hit the second key, and you can hit the enter key, and that will bring up your previous entry, and then you can scroll to the left here and change your entries. With the new school calculators, it's easier because you could just go into the submenu and change them. But for the old school calculators, that's a little bit tougher to do. So second and enter to get your previous entry, and then you can modify any numbers that you got. If you were to modify it with previous entry stuff, you just have to make sure to use the insert key. Like in this case, I want to delete this, and then maybe I hit second and delete, and I want to insert 0.40. There you go. And make sure I hit the right arrow. Now I can hit 0.45. There you go. Easy peasy lemon squeezy. And that is correct, Jasmine. Right. 0.3203. Good. All right. Very good. All right. Any questions about that? Any questions about that one so far? Nope. All right. Hopefully that's pretty simple. All right. So far, so good. Okay. Let's take a good look here at the next one. So you may see a problem that looks like this in part D. Okay, so we're gonna look here at part D. It says, would it be unusual for a random sample of 500 adult Americans to result in 210 or more who believe that marriage is obsolete? Now, if you see this type of problem here, all right, the way you want to attack this particular problem is basically going to say probability of, again, 210 or more. As you can see here, it's going to be 210 out of 500. So that's what you have to figure out here. If you have a certain amount of people that you surveyed and says 210 people or more said yes to my question, they believe marriage is obsolete, then really what you're looking for here is exactly as it says here, 0.42. Again, 42% or more, okay, is what we're looking for here in this instance. So as you can see right below. Now, the real question is, since we're looking at 42% or more, all right, the real question is what we enter in. Now, again, we are still going to be using Normalcdf just like we did in the previous few problems. So that part really doesn't change too much. Now, the real question is that I'll give you guys is what numbers are we going to use here in order to solve for this problem? All right, now the last two numbers are going to be the same because those don't change. All right, so the mean is still 0.39. So just know that these are not changing because we are not changing the sample size or nothing. Okay. So just letting you know. Last two numbers do not change. Mean and standard deviation the same. What are we going to put here in front? 0.42 or more. What are those first two numbers going to be? All right, 0.42 and 1. That is correct. Very good. That's right. So, good thing, good. Picked up on that very quickly. So 0.42 to 100% of 1. Right. So let's plug that in the calculator here, and let's see what we get for our probability. So second invars, we'll hit 0.42 of 1. Not sure why this did not save, but okay. I'll have to do it again. Please register 0.39. Great. Go. 1 is reflective of 100%. So remember, 1 equals 100%. Right? Remember, don't forget, we're dealing with percentages here. We're dealing proportions, guys. We're dealing with percentages, right? When we say 210 over 500, that's 0.42. That means I want to see, you know, what's the probability that 42% or more people said yes to the question, right? That's exactly why we're going up to 1 here in this instance. All right, so here we get 0.0845. All right. Any questions about that? Hopefully that's not too bad. Nope. Pretty easy. Want to be sure. Do we have... Pretty sure here, but I'm not sure about that. Perfect. Fine. All right. We go and look at that. Good problem. That's where I want to be. Gotta find the right page. Alrighty. Okay. Let's take a good look here at another problem really quick. All right. So the next thing that we're going to do here is let's talk about number 20. Let's see. Did I ask? I think I asked a question about that, actually. Did for... Alright, give me just a second here. Maybe I'm mixing two sections up together. Make sure. I think I am mixing two sections up together. Alright, let's do one more then. That's fine. I'm mixing two things up in my head, so... Alright. Okay, let's look at one more here from this section. Let's look at number 18. All right, number 18 says, according to creditcard.com, 29% of adults do not own a credit card. All right, suppose that a random sample of 500 adults were asked, do you own a credit card? Okay, so let's say we assume that we asked 500 people. What is the probability that in a random sample of those 500, more than 30% do not own a credit card? Okay, so let's go ahead and do that. All right, so let's say, again, we have a sample size here of 500. What is our, what's our P here in this case? Go back to our problem here. What's our P here in this case? What is P? Equal to 0.29. Good. That's right. Very nice. All right, so that's our population proportion there. All right, we're asking 500 people, like, all right, you own a credit card, yes or no? They say 29% of people says, you know, I don't own a credit card. Fine. All right. Let's do the first part then, now that we have that all set and ready to go. Okay, so we want to find the probability of more than 30%. We're just going to answer two parts here, so more than 30%. All right, so can you guys tell me what numbers are we going to enter in to the function here? So we're going to use Normalcdf. What numbers are we going to use here? All right, that's correct. Very nice, Alex. That's right. So more than 30% will be 0.30. We'll go up to 1. We'll go up to 0.29. And then we'll have exactly that correct here, 0.29. 1 minus 0.29. And then we'll divide that by 500. All right, sounds good to me. Okay. Okay, and does anybody have an answer for me here? Let's check it out. Let's second in vars. We'll go to Normalcdf. 0.3111. Okay. Change this up a bit. Yep. All right. I trust. Yep. Okay. That is correct. Okay. All right. So far, so bueno. Very nicely done. All right. So we're going to do one more here. We're going to do one more. All right. I'm going to do that last part there. It says, would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? So would it be unusual if we have 125, we surveyed and we said 125 people or fewer said that they do not own a credit card? So we know from before that unusual means less than 5%. So we know that for a fact. That's our metric that we have to use here. But less than 125 or fewer, what exactly is that proportion there. What kind of probability are we actually trying to find here in this case? Let's take 125. Let's what proportion are we really looking over? Not in this case, Vince. Think about it this way. Not how many people have a credit card. This is about people who do not have a credit card. So 125 fewer who do not own a credit card. So I'm not looking at the complement here. I'm just looking at it straight. So how did I do the last problem there? Let's take a look at the last problem there. Oh, okay. So 125 over 500. Okay. That's right. So we're going to look at 125 over 500. So we're looking at, 25%. That's right. So in this case here, right, we're looking at the probability of 25% or 0.25 or less, right? That's what we want to be looking at here. All right, so hopefully everybody understands where I'm getting this from here, at least setting up this problem. We're looking at 25% or less here, trying to figure out that particular probability. All right, so what are we getting here in this particular instance? What numbers are we gonna put in, and why, and all that jazz? How are we gonna figure out this probability? Normal CDF 0.25 and same as before. Okay, very good. That's right, Alex. Good. We'll use normal CDF 0.25. Alright, we'll use 0.29. And we'll use the same exact guy here. I'll just kind of point this here. Writing that in takes a long time. Alright, so let's see what we get here. There we go. Okay, so we need 0.25, and the rest of this is the same. Okay, so Jasmine's correct, yes, 0.0244. So would this be classified as unusual, yes or no? Would this be unusual, yes or no? Yes, okay, good. Right. Alright. Very nice. Alright. It is definitely less than 0.05, but definitely unusual. Alright. Any questions over section 8.2? Any questions about that section? Okay. Now. And alright. So here's what I'm going to do about this guy right here. Now, and this is effectively the end of chapter 8. All right, this is effectively the end of chapter 8. So what I'm going to do here specifically in this particular instance is the next test here is over chapters 5 to 8, as I mentioned here last time. I'm going to bring this up on screen here. All right, So, once again, I'm going to make the announcement here as I said, as soon as I felt be comfortable here finishing up Chapter 8. Then we can go ahead and announce when the homework will be due. So the homework and test here is going to be due in 2 weeks from today, which is going to be the 2nd of November. Okay, so the 2nd of November here is chapters 5, 6, 7, and 8 is when the homework and test will be due. Okay, homework and test for chapters 5 to 8. I'm just going to put this in chat. 2 on the 2nd of November. Okay, so go ahead and change those due dates now so you can see that I'm doing it right in front of your face. So I gave you 2 weeks last time, so I wanted to be consistent about how much time I'm giving you this go around. I didn't want to skimp, so I'll be like, all right, let me be consistent from what I did previously. No problem, Sneaky. Appreciate that. Oh crap! I didn't mean to do that. Alright, I gotta do this again then. Alright, chapter 5 again. I forgot that. I'm thinking that everything that I checkmarked is like, okay. Alright. Everything. Okay. That doesn't count because we're not even doing that section. Alright. Alright, let's see. And those should be changed. Yes. Okay. Alright. So those should be effectively changed there. And then I will effectively also change. I want to be transparent, so I'm just showing you that I'm doing this. So that way you're like, oh, he never changed it. And be like, bro. It's right there. Okay. Yep. Gotta have the receipts. You know, receipts are number one. You can't deny when you got the receipts. That's how it works. This actually I'm going to change. This one I need to change back. All right. All right, there we go. Got that all set and ready to go. Perfect. All right. Excellent. Okay. Good. Very good. All right. Do you guys want to take a break or do you guys want me to keep going? What do you guys want me to do? What do you want me to do? Take a break or keep going? No break? No break today? Break? Break is good? So people say break. All right. All right. So we'll take a short break here. Okay, short break. All right. Tell you what, we'll come back in 8 minutes. We'll do a short second half here, but 12:15. Let's come back at 12:15, and we'll do the second half, or the modified second half. We're on a good pace, guys. We're on a good pace. All right, trust me on that. We're on a very good pace. All right, so we'll come back 12:15.
heating homes, cooking. Oh, you make me wanna talk back to you. Say it like that. If I hate you, then find someone new. Baby, but you know I never will. No, so I choke you down just like a pill. Don't let me sleep. Never say sorry. Oh, maybe I'll leave. Baby, but you know I never will. No, so I choke you down just like a pill.
All right, we are back. Okay, welcome back, everybody. Welcome back. All right, I'm gonna go ahead and keep moving forward here with what we're doing. We'll see how far we can get here with the material here today in section 9.1. But we should get at least through probably halfway through the material here, at least in this first section here of section 9.1. So let's at least go ahead and do that here for the last 25 minutes or so, and we'll get moving with that. All right. Okay, so let's talk about that. Okay, so the first thing that we're going to talk about here is switching to the big screen here. That's the first thing we'll talk about. Okay, so we're getting into chapter 9 now. Chapter 9 is going to be, again, going to be a few sections here. Not two sections. There'll be like 3-4 sections in this particular chapter, but not the ton of content, I suppose, in these particular sections. However, I will say this again. This is where we start, kind of moving up a little bit. This stuff here, in all honesty, is not too hard, in my estimation. Now, we're going to be using the same concepts that we just talked about here back in section 8.2, at least on this first front. So we're no longer doing, say, normal distributions or whatnot. That's not what we're doing here in Chapter 9. Instead, and what we're doing here in Chapter 9 is we're doing what's called a confidence interval. Essentially, these confidence intervals are going to be ballpark estimates that we can take, basically extrapolating from a sample that we take. So let's say we do a survey of some time and extrapolating that to a whole generic population and saying, okay, between this percentage and this percentage, we think that you have, A, B, and C, maybe support for, like, let's say it's a political candidate. Okay, let's say, oh, I have a support for this candidate. And, you can talk about, okay, this candidate has X support. Or this candidate, or again, brand A, brand B, you could always compare the two. Says, oh, brand A has X amount of support with, with a variety of margin of error. So if you see here, let me actually bring this up here in a realistic setting. You guys have seen this before. It's up here. So we go to Real Clear Politics. Now, like I said, I'm not talking about politics on this channel exactly per se. What I actually want to specifically look at here is just say, okay, let's look at the latest polls, okay, just as an added example here. If I look at the latest polls. Now, if I look at the latest polls, yeah, I'm going to bring up the notes here for 9.1, Jasmine. So if I look at the latest polls and I say, okay, who's... what do you think? Who's going to win the Virginia governorship? I've barely been keeping track, but you can see here that both of them are at a virtual tie, or again, there's a spread here. If you take a look here specifically at this chart, one of the things I like about this website, it does at least hold some actual educational value, is they do give you the sample size here. So, for example, they give you, say, hey, I took this poll. This particular group took a particular poll here between the 11th and the 13th. They sampled 1,095 LV, stands for likely voters. And they say, okay, well, each of them got 48%, so that would be a tie in this particular case. And then we also see here next to this is this MOE. Now, this MOE should be, again, stands for the margin of error. So essentially, it's either plus or minus 3 points. So when you're in a virtual tie, it's exactly as it sounds. You're within that margin of error. Means, hey, this pretty much they're tied here. If you're both within that margin of error. If I were to look at this and I say, okay, well, this candidate got 51%, this candidate got 46%, the margin of error is 3.5%. The reason why, because you asked fewer people. Well, then you say, okay, is this within the 3.5% margin of error? If not, then you can say, okay, this candidate is slightly ahead of this candidate. Okay, whatever the case may be. All right, politics aside, party aside, that's all we're looking at here is essentially the numbers here. And what we're trying to establish is exactly how we can come up with these particular confidence intervals and actually how we can actually come up with the margin of error in those particular cases. All right, that's essentially what we're looking for here in this particular instance. All right, so let's take a look here at question number 1, and then we'll work our way down here for the notes here for section 9.1. So we did talk about this before in section 8.2, just not too long ago here today. That is talking about what is the population proportion. So we talked about this. We said, hey, P is the population proportion as the notation. P hat is X over N, which is the sample proportion. Same stuff as we just did in the last section. Again, X, the number of people say yes, and N here being the sample size. All right, fine. Now, there are 2 conditions that we must make here if we're going to make a proper confidence interval. And we'll expand on this here. So what assumptions must we take here for constructing a confidence interval with the population proportion P? First of all, if we take n p hat times 1 minus p, that has to be bigger than or equal to 10. That's the same thing that we talked about here back in section 8.2, where we had say, hey, I need a big enough sample size in order to establish this particular probability, I need a big enough sample size to establish a confidence interval. Okay? If I only ask, again, it goes back to the principle here. If I only ask 10 people aren't going to tell me anything about how everybody else feels. So, in our example, we looked at, say, the Virginia governorship. Well, I'm asking, if I ask 10 people in Virginia, who they want to vote for governor, yeah, that ain't going to tell me what the state's going to actually think about who they want to vote for governor, okay? So you want a sufficient enough sample size with the particular metric here. In this case, NP times 1 minus P. That's why asking like 1,000 people makes a whole lot more sense over time. All right? And then we also have N here. Here's another metric here. One of the actual interesting metrics that we also follow here is that the sample size here has to be less than or equal to 0.05 of the population size, i.e., pick a sample size that's large, but not too large, okay? So we want to pick a sample size that's sufficiently large enough, but not 5%. We want it to keep less than or equal to 5% of the population size. Now, of course, in a state like Virginia, in our, quick political poll, that is pretty easy to do, to keep it below 5% of a very large state like Virginia. But if you ask too many people, that'll actually skew the results as well. And not only that, but it, typically that's a pretty expensive endeavor, all right, to have an entirety of a population. Hence why, if you remember, taking a census like in the United States, we only do it once every 10 years because obviously doing a census every year would be incredibly expensive and incredibly time consuming. All right, so keeping it under a metric here of 5%, we can make some general conclusions from the sample to the population. All right, so the question is, how do we go ahead and find out how to find these particular confidence intervals? Let's take a good look here. We're going to use what you see here on screen. We're going to do this stuff together here. We'll use the calculator, of course, of which to do this. But we need to see an example, and we need to go do this. By the way, I'm going to switch back and forth here. So just give me a second while I look at the book. I'll present that to you, and then we'll look at the actual thing. All right. So we're going to look at number 27 here from this section. All right. So let's look at 27. Okay. Now, let's go ahead and read this off here. So, a random sample of 1,003 adult Americans was asked, do you pretty much think TVs are a necessity or a luxury you could do without? Of the 1,003 adults surveyed, 521 indicated that TVs are a luxury they could do without. All right. So we're going to answer one question in here. Okay, well, we'll answer a couple questions in here, but first and foremost, let's answer question A. Sometimes you'll get this idea, so if you see this question, you'll know what this means. Okay, letter A. Obtain a point estimate for the population proportion of adult Americans who believe that TVs are a luxury they could do without. Okay, so in this particular question here, it's when you construct a confidence interval, you want a starting point, okay, of which you want to work from here. Remember, all confidence intervals is basically kind of like a ballpark estimate of people saying yes to your particular question. In this case, people could say yes to the question that, yeah, I could live without TVs. I think that they're a luxury I could live without. So that's fair. All right. So if we want a point estimate here, we just look at the raw data, okay? I said let's at least get a starting point here. That's what a point estimate will allow us to do. So we asked the question to, in this case, 1,003 people. All right, and 521 said, hey, you know what? I could probably do without a TV. I said, all right. So that's going to be our point estimate. 521 here is going to be X, the number of people who said, yeah, I could do without a TV, out of the 1,003 that we actually surveyed. So we want to plop that on the calculator here. Okay, and so you could write this down if you want, 0.519, that's fine. Actually, I'll go out one more, 51944. Okay, so this is a point estimate here. the more important part I want you to take away from this is not so much the answer here in this particular case, because that's the question that they asked, is actually the two numbers that we see here. Because the two numbers here will prove to be fairly useful. We have x here, specifically, is going to be 521. That's the number of people who said yes to our question. And the sample size here being 1003. Okay, so we're going to definitely take both of those into account here for what we're going to be doing next. Okay, I'll show off what that means in just a second. Now let's take a look at letter C. Okay, so I'm going to skip over here letter C and we'll talk about a couple things. Letter C, construct and interpret a 95% confidence interval for the population proportion of adult Americans who believe TVs are a luxury they could do without. Now, one of the things in these confidence interval problems that we are going to be looking at here is we're going to be looking at different confidence levels, okay, meaning different percentages. So, different percentages here. So, we want to look at it, in this case here, we have a confidence level of 95%. So, I'm going to point that out here. We'll talk about what that means here in just a moment. But I'm just presenting it one piece at a time here. So we have a confidence level here of 95%. Now, if we were to do this by hand, there would be some critical value that goes with this 95% and whatnot. But that's not what we're doing here. We're going to take our nice little shortcut method here. We're going to find out what this confidence interval is. And then from that, we're going to talk about exactly what that means here in the context of this problem. All right. So let me go back to the handout here. And now we're going to take a look here at exactly what this is going to refer to. So first and foremost here, we're going to use something that's called one prop z int on the calculator to determine the confidence interval. Now, that's what we're going to use here. We'll talk about what we need to put here. Okay. Now, no matter what, if you have the new school calculator, if you have the old school calculator, each of you will have the same submenu that you're going to see here. So ironically, new school calculator, old school calculator, there's actually literally no difference. So fortunately for us, we don't have to worry about that. Let's take out our calculator here. Again, we have our numbers that you can see here. We have x is 521, n is 1003. We have our confidence level at 95%. Right. So, what are we going to do first? All right, let's hit the stat key here. And we're going to go to, over to tests. Okay, so let me type that in chat here. Hit the stats key, and then go over to tests. All right, that's what we're going to do here. All right. Now, the next thing we're going to do here, be very careful about this, guys. Be very careful that you're not picking the wrong one. We want to go down to one prop z int, int. So, we are not picking number 5, okay? Do not pick number 5. We are actually going to go down to letter A, which says one prop z int. Letter A, one prop z int. Int representing interval. Okay, we want to find a confidence interval. And then hit enter on that. So be a little careful about that. That's the most common button press that you get wrong there. Okay, now before we enter in some numbers, which are pretty easy to see, we want to be sure is everybody here at this submenu? Old school calculator, new school calculator, is everybody here at this subinterval? Please type in done if you are here at this submenu. All right. So did you go to stats? So Sneaky, read up what I type. Read up on the chat log there. Okay, so you go to stats. You go to tests, okay, and you found it. Okay, good. You go to stats, you go to tests, which is, you scroll over to tests, then you scroll down to letter A, which says one prop z in. That's all I want you to do. Let me know once you got there, Sneaky. All right, everybody there? Sneaky, did you get there? Okay, cool. All right, so now that we're on this little sub-menu page, let's go ahead and enter in our numbers here. And this is why I wanted you to write down the numbers here specifically. Because now, as you can see here, we have an X, we have an N, and we have a C level here. So, which is going to be our confidence level. So our X here, as we know, is 521. Our N here is going to be the number of people we asked in this question, which was 1,003. No problem, Sneaky. Gotcha. And then our confidence level here is going to be 95%. Now 95%, again, we're not going to put 95%. You're going to put in the decimal equivalent here of 0.95. So put in that decimal equivalent here for C level of 0.95. I know that defaulted to that before, but I wanted to make sure that you understood that we're using the decimal equivalent here for every percentage. Then we'll go ahead and go to calculate here, let it do its thing. Okay. Now the things that we care about here is going to be what you see up top. Okay? What you see up top is going to be the two numbers that we want to look at here for our confidence interval, which is going to be 0.48852 and 0.55036. Okay. And then they show off a P here. Again, as you see here, this is the point estimate that we started with. So remember, this was the part A. This is what we started with, the point estimate stuff. And it just give you the sample size. All right. In any case, this is our 95% confidence interval. All right. This is our 95% confidence interval. Now, yeah, so some calculators will... Okay, Alex, to be fair, some calculators will round to 4 decimal places. Some will round to 5. I think maybe the newer style calculators go to 5, but it depends. I wouldn't worry about that too much because we do want it to either 4 or 5 decimal places. The homework, I'm pretty sure... Yeah, the homework I know for sure will go to like 4 decimal places and you'll be fine. So you should be taken care of regardless. So either way, you can use new school calculator, old school calculator. You'll be perfectly fine. Okay. Okay. So, let's talk about a couple of things here. First of all, we can talk about the margin of error. Now, if we talk about the margin of error here, the margin of error is if we take the point estimate and take the difference between either one of the ends of our confidence intervals. So if we talk about margin of error, we just take our point estimate, whatever it may be, or again, whatever your halfway point is going to be, and you could take, let's say we take 0.55036. That's our high end of our confidence interval. Subtract that by 0.51944, and so we can see what our margin of error is going to be. Excuse me. We'll just go ahead and do that here. This is exactly, by the way, how they go ahead and find out these things. So here the margin of error would be 0.03092. So for example here, I would say, all right, margin of error is like 3.1% or something like that. And I would make a note of that. And I would, like, if it's like the political poll, for example, that's what I would note my margin of error to be. The 0.51944 came from the first part here, the point estimate here. Oh, you can't see that. Let me move that up. Maybe be a little bit tough for you to see that. Yeah. No, that's my fault. I forgot that's hidden by my face. All right. Confused? Confused regarding what, Jasmine? If you have a question, please ask. We took so we took the extreme end of the interval here. You just take one end of the interval here, Jasmine, and you can subtract it from the point estimate here. That's all you have to do. So I just took the high end of the confidence interval and subtracted it by the point estimate to get the margin of error. So let me put that down here. So just take you either do one of two things. You take the high minus the point estimate, or you can take the point estimate and subtract it from the low. Because if you went ahead and said, okay, what's 0.51944 minus this 0.48852, you'll get the same answer here. Okay, there's no difference. So you could either do one of two things. So that's what effectively we're doing here in this case, okay? Now, all right, I'm kind of running out of time here. I do apologize. I do have to kind of showcase one thing here. Very important. One of the things that you'll be asked in this section here is to be able to interpret this confidence interval. So you're like saying, all right, I got these two random numbers of 0.488 whatever and 0.550 whatever. What exactly does it mean in the context of the problem that we're looking at here? Okay, because that's something that will be asked here for pretty much every single one of these questions, is the interpretation of said interval. So, if we talk about the interpretation of said interval, let's take a look at what this means. In this case, remember we had a 95% confidence interval. Okay, so if I said, all right, the way we view it is, we say we are 95% confident, because 95% being our confidence level, that the proportion of all adult Americans who think TV is a luxury is between, in this case, 0.48852 and 0.55036. The key word here being the proportion of all. Remember that we're taking it from a sample and we're now extrapolating that to the entirety of the population. Hence why we have the proportion of all here as part of our interpretation. So now we can say we're 95% sure, we're 95% confident that somewhere between 48.852% and 55.036%, people think of all adult Americans think TV is a luxury they could do without. Okay. And if you want to be super extra sure, let's say you want to be super extra sure, you could increase that confidence interval. Let's say you want to be 99% sure between what values, what percentages that people think TV's a luxury they could do without. Watch what happens here. So let's say I did the problem again, but let's say I just changed one number. I'll show you what happens here. We'll look at another example here for next time, but let's say I change the confidence level to 99%. Say I want to be 99% sure, of what the actual value of what all adult Americans think, based on what I have. If I want to be 99% sure, take a look at our confidence interval now. Now our confidence interval is between 47.881% and 56%. So it's a wider interval than it was before at 95%. Meaning if you want to be extra sure, you're going to need to go from this narrow point of view and you need to widen it just a little bit more to be extra, double extra sure. So hence why we say, hey, if you have a higher confidence level, the wider that confidence interval is going to be at the end of the day. Okay, so the bigger the confidence level, the bigger that interval is going to be. All right, because we're going to have to include more percentages to make double extra sure. All right, are there any questions about that? We're going to look at some more examples here for next time, but for right now, we've got a good start here in at least talking about confidence intervals. All right. Very good. Okay. So that you should do up to section 8.1. Oh, not 8.1. Sorry, Vince. First things first, Vince. Sorry. I think I should probably say first. First things first, Vince. Focus on everything up through chapter 8 so you can get prepped for the homework and the test. All right. Once you do the test, that should be the first priority. And then after that, try chapter 9. So that is what I would say to do. Focus on everything from chapter 5 to 8 that you haven't finished. Do the test. That's, of course, do the practice test before the actual test. And yeah, that's my suggestion for you today. So priorities first. First priority, and then second priority would be to do chapter 9. Cool. All right. All right, everybody. I want to thank everybody for coming out here to stream once again. All of you, absolutely fantastic job today. We actually got a lot of stuff done. We're now into chapter 9. We're now into the last third of the textbook. So we're getting there, folks. We're getting there. All right. Next time, we'll continue on with chapter 9, and we will keep on going. Great job, everybody. Focus on that homework and tests. Make sure you get that started ASAP so you don't have to worry. Yeah. That rhymes. All right. Thank you so much, everybody. I hope everybody has a wonderful rest of your day. We will come back here in a couple days' time. All right? In a couple days' time, we'll come back here. I hope everybody has an absolutely fantastic day. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? Take care of yourself, everyone, and we will see you all then. All right. Take care, everybody. We'll see you later, everybody. Take care. All right. Bye. Contact me on Discord or email if you have questions, of course. See you guys.